Okay, welcome back to a new math tutorial. In this video I would like to explain how you can calculate the distance between any arbitrary point and any line in 3D. And in order to do that, I created here this exercise which says calculate the distance between the point, in this case 258, these are the coordinates of the point, and the line L, which is given by a vector x equal to 1, 2, 3, which is the position vector, plus lambda times the direction vector minus 1, 7, 4. Yeah? So I think when we go through this exercise, this is quite instructive. And then after that, you know how to do this for any arbitrary point and line that you find in certain exercises. So now I will show you the method, how to do that. And in order to explain this, first let's make a sketch with any arbitrary point P and a line that we draw here and which we call in this case L. And now what we can do, we can define a few vectors which are very helpful for understanding this method. And the first one would be maybe the vector from the point P to the line L. And this is our distance vector, which we call D. And now the question is, of course, to which point do we have to calculate the distance? Because we could use any arbitrary point on this line. For example, we could calculate the distance from here to here, or we could calculate the distance from here to here. But of course, it would only make sense to calculate the shortest distance. Yeah? And the shortest distance is, of course, the one where this vector D intersects this line perpendicular. So we have a 90-degree angle here. And when we have this angle of 90 degree, then it means our distance is as short as possible. And this is then what we define as the distance between P and L. Yeah, but for our calculations, we would need a few more vectors actually. What we need is, for example, here, this direction vector of our line. Yeah, let's call that maybe U. This is this vector here. And what we also need to make essentially in order to do any calculation is to create a vector from an origin that could be, for example, here to that point P. Yeah, so we could maybe draw it in such a way. This is our vector, let's call it maybe R. And we can also create a vector from the origin to this point, which we call maybe base point B, and this vector we call S. And when we do that, we can immediately see that now our vector D can be written as the difference S minus R. Yeah? So it could be also R minus S, then we have to swap the vector, but it doesn't matter so much because at the end we are only interested in this absolute value of D, because the absolute value of D automatically gives us the distance. And now we can already see how this method actually works. So what we have to do, I can write down the algorithm actually which you have to apply, and you can always use the same algorithm. You don't have to change it actually. Whenever you have a similar exercise. So the first thing which we have to do is, of course, to understand what condition must be fulfilled in order to have the minimum distance. And as I said, we need this 90-degree angle between D and L, which means that the dot product of D and this direction vector U must be 0. So what we do, we have to calculate in the first step the dot product of U times D, or I think I will do it later in a different form. I will just change the order, but it doesn't matter. I will calculate the dot product of D and U, and this has to be equal to 0. And when you do that, you get the line parameter from that. So this lambda, and this can be determined. Determine the parameter lambda. And the third step is when we have lambda, we have to insert it into our vector D that we have noted down here. and then we can calculate the absolute value. Yeah. So maybe we can write here calculate the absolute value of D. Yeah, and this absolute value, as I said, is the distance. Okay, so what we can do, we can create a new page, and then we can actually start with our exercise solution. Yeah, so of course, first, as I said, we have given here our line, which is x equal to 1, 2, 3 plus lambda minus 1, 7, 4. And we also have given our point P, and we can directly convert this into our vector R, because as I said, this vector R points from the origin to P, which means that we can write directly here R equal to 2, 5, 8. Yeah, these were the x and y, z, x, y, and z coordinates of our point P. Yeah. And now what we do is calculating this dot product d times u, and this, as I said, has to be 0. So what we do is actually inserting here this difference s minus r times u equal to 0. And for s, we can of course insert our line equation, or our line equation. So what we have here is s points to this point here on the line, which means we can directly insert this part here, and our vector r points to P. Yeah. So what we can write now, and u is also given. This is as I said, this direction vector of the line. So what we can write now down here is 1, 2, 3 plus lambda minus 1, 7, 4. And this is our s vector minus, and then we have to write 2, 5, 8, our point P actually. And then this whole part has to be in brackets, times minus 1, 7, 3, and this has to be equal to 0. And now we can, now the only thing which we have to do, in principle, this is already half of the exercise that we have to solve. So what we can do, we can actually subtract this vector here from that one, and also write it as one vector. Yeah, so this sum of 3 vectors we can directly insert in one vector, of course. So this would mean that we can write here minus 1 minus lambda minus 3 plus 7 lambda, and here minus 5 plus 4 lambda. And all that, this is this vector here, just vector addition and subtraction, times minus 1, 7, 3 has to be equal to 0. Okay, and then we have to only calculate this dot product here, and this gives 1 plus lambda, so the product of the first coordinate, minus 21 plus 49 lambda minus 15 plus 12 lambda equal to 0. So what only thing which we have to do, we have to actually add up these numbers and also these lambdas which we have. So I have done this already before, and this comes, or this turns out to be minus 35 plus 62 lambda equal to 0. Yeah, and then of course the last step which we have to do, we have to solve that for lambda, and this gives not 35 over 62. Yeah, this is our lambda parameter. Yeah, and then we actually almost have it. So the next thing which we have to do, we have to inserting lambda into D, into our vector D, as I said before. So when we do that, then we get here D equal minus 1 minus 35 over 62, and here minus 3 plus 7 times 35 over 62, and here we would get minus 5 plus 4 times 35 over 62. Yeah, and then this is of course a vector, and the last step, of course, as I said, you have to calculate the absolute value of D. Yeah, so this would be then given as, and now we have to draw actually a very long root, and this would be, or square root, this is minus 1 minus 35.62 squared, the first component, plus, and this is just simply calculating the absolute value of a vector, minus 3 plus 7 times 35 over 62 squared plus minus 5 plus 4, 35 over 62 squared. And as you can see, it fits perfectly inside. And yeah, I've done this also before. And when you calculate this, when you add up all these square terms and then calculate the square root of that, you actually come to the result of 3.29 units. And of course, if these are coordinate units, so if your units were meter, then this would turn out into meter. If it was millimeter, it was millimeter. But here we just calculate with arbitrary units. So the distance between this point here and this line, the shortest distance, would be in this case given as 3.29 units. And this is a quite remarkable result, I think. So just to summarize this again, the idea is that first you calculate the dot product between D and U, which we have done actually here. And then when you have written down this product, then you can determine lambda, which we have done here. And then at the end, you can insert this back into your vector D, calculate the absolute value, and then you get the result. And as I said, you can calculate any kind of exercise in the similar way with this. The same you could also do in different other forms. For example, the distance between the point and the surface of an object or something like that, which will be a little bit more complicated. This I will maybe cover in another video. And if you are interested in this, please write it into the comment section, or if you want to see any other topic to be covered. Yeah, and otherwise, I hope that you learned something new. I hope that you liked the video. If you like it, please hit the like button. Please insert some comments. And if you have not subscribed my channel until now, I would be really happy if you do that in order not to miss any further videos, and hopefully see you soon now for a new math or physics tutorial.